So this is a really interesting problem. I've never done a concept like this before. But they want us to use this table of values to look at the different, really, derivatives. You have the first derivative, the change in f. You have the delta squared, the change squared. That's the second derivative. Or the change in the change. And then the triple layer of that, the third derivative. So basically what you can do here is, like, if we find the slopes, well, here, I put it on my iPad. So there's the same numbers copied down. So what we're going to do, here's our first derivative. And, well, here's our first derivative. And that's just going to be the change. So this goes down by 10. So that's negative 10. And look how in the original picture they have that top box grayed out, because you can't calculate the slope for the first point. And same with the 2 on the second derivative and the 3 on the third derivative. You need, like, the other points to calculate them, which we'll see if we go back here. So what's the next one? Here the change is 0, right? Because it just stays the same. And let's just do that all the way down real quick. So then it goes up by 16. It goes up by 54 minus 16. 38. And you got to be careful with this. If you mess up the numbers, it's not going to work out. And then 120 minus 54, 66. So see, that's just the slope between all of those points, all of these x and y points. And then now for the second derivative, well, then here too. So if it was a first degree linear equation, it would have a constant slope. All those numbers would be the same. And that's not true. So then let's look at the second derivative, or the acceleration. So there we're saying the acceleration goes up by 10, up by 16. So acceleration is just change in the slope, change in the speed. So we're just looking at how the speed goes up now. And then 16 to 38 goes up by 22. 38 to 66 goes up by 28. And so if it was a second degree polynomial, the acceleration would be constant. But it's not, so then we continue on to the third derivative. And now we see, so the third derivative is the change in acceleration. It just goes up by, like, layers. So now the change in acceleration, it goes up by 6, it goes up by 6, and it goes up by 6. So now we did find something that's constant. So that means it's a third degree polynomial. Or like an x cubed. I can't spell, but you get the idea. So it's like an x cubed function. So we know when we try to write it, we should think about we're going to have 3 different sets of parentheses. X minus something, x minus something, x minus something. And then maybe a number multiplied on the outside, right? So we have some number multiplied on the outside. Maybe it's 1. Maybe it's some other number. And then all these different factors. But here's the thing. We know 2 of the factors already, right? Because we already know 2 of the x-intercepts. We know that when we plug in x equals 2, we get 0, and x equals 3, we get 0. So one of them is x minus 2. The other one is x minus 3. And the other one, we don't know. So can throw in like x minus b. So there's our function. And then now, what they want us to do with this system of equations is they want us to use 2 of these points, plug them in for x and y. Because then we'll have 2 equations with our 2 variables, a and b. And so then we'll be able to solve for a and b, and then we'll know what the polynomial is. So first, just choose the easiest points we can. We'll plug in x equals 1. So when we plug in x equals 1, we get a times negative 1 times negative 2 times 1 minus b equals 10, right? X equals 1, y equals 10. And then let's simplify that just a second. So negative times negative is positive. So we have 2a times 1 minus b equals, not yet, 10. But I will say the next thing we might as well do is divide both sides by 2. So a times 1 minus b equals 5. And then we'll just choose another point. And we can't do the 2 and the 3, because look how if we plug in x equals 2 or 3, we'll just end up with one whole side being 0. So that's not even helpful. We need to go to x equals 4. So now let's plug in x equals 4. So we'll have a times 4 minus 2 times 4 minus 3 times 4 minus b equals, what was it, 16. Simplify that real quick, divide both sides by 2. A times 4 minus b equals 8. So now we have two equations and two variables, so we can solve for them. And so you can do this in a multitude of ways, I'm sure. I'm going to use substitution, so I'm going to solve both of those for a. We'll make that a equals 5 over 1 minus b, and that a equals 8 over 4 minus b. So then now we can do a substitution and solve for b. Just set these equal to each other. 8 over 4 minus b equals 5 over 1 minus b. And we just got a quick algebra equation we can solve now. So I'll cross multiply and distribute. 8 minus 8b equals 20 minus 5b gets us with 3b and negative 12. So b is negative 4. And then lastly, we just got to find a. I'll go ahead and plug in b equals negative 4 into this one. Ooh, that looked scary for a second, didn't it? But no, we end up with a equals 8 over 4 minus negative 4, or 8 over 8, or 1. So it turned out that number in the front didn't matter. But now we can find our polynomial by plugging everything in. We have 1 times x minus 2 times x minus 3 times x minus negative 4, or x plus 4. And that is our polynomial. Just to complete it out for you, just in case, if you want it in the distributed form. Not as useful as the factored form. It's probably more useful to keep it in the factored form, but we'll distribute it just in case. So we'll FOIL the first bit, and then distribute that with the second bit. And my tip with distributing longer stuff like this is, like, let's line it up. So I'm going to do x times x squared minus 5x squared plus 6x, and then plus 4x squared minus 20x plus 24. And then we'll just add them together. X cubed minus x squared minus 14x plus 24. And that is our polynomial. Just to check our answer, let's plug in 5 real quick. See if we get what the number was. So we plug in 5, 125 minus 25 minus 14 times 5, 70, plus 24. So let's see. That combines, that's negative 1. 125 minus 70, that's 55. So we should end up with 54. Is that right? Yes. So there you go. There's your polynomial, depending on which way you want it.